Okay, so this is just the definition of activation energy. So all this graph is showing is that on this side, this is the reactants, right? And then this side is the products. So what happens is when the reactants need to, and all a chemical reaction is a bunch of molecules hitting each other hard enough so that they become products. And so what this curve right here is that when these molecules, these reactor molecules, are hitting each other, they need a specific speed that they need to they need a specific speed so that it'll break, or it'll become temporarily a different molecule. Like the bonds will be broken a little bit. So this is called activation energy right here. This amplitude right here is activation energy. So this is the activation energy, like the speed required to temporarily break the bonds. And then because energy is being distributed into the molecules, the potential energy goes up, but that's okay because then it can achieve a more stable state, which is the entire purpose of molecules, to achieve a more stable state. So it has this activation energy, and then after the bonds are broken, if it still has enough energy, it becomes a product. And so the reverse reaction is actually from the products all the way to the amplitude. That's why. So this now, the entire line would be the reverse activation energy. And now and that's why the reverse reaction is slower than the forward, because it takes more energy for the product to go back into a reactant. So and then the change from the reactants to the products right here, this distance is it's the change in enthalpy. And so that'll let you know if it's endothermic or exothermic. For this one, it's going to be negative, and that's why it's going to be an exothermic reaction. And then if you had another diagram, the same one, except it was above, this would be an endothermic reaction. This would be the reactants. This would be the products. But the activation energy would actually be less, obviously, since it would be over here, and then this would be the activation energy. And then finally, the change would now be positive. And you can see that just by, if we put like fake numbers. Let's say this is 50 and this is 40. Final 40 minus initial 50 makes it a negative number. But over here, if you give it a fake number of 50 or 60, right? Final 60 minus initial is a positive number. And a positive number is endothermic, and this would be exothermic.